Alright, this is video 3, going to cover terrain stuff from this quarter, so this whole page right here. Okay, so first off is the asset manager stuff. So the terrain object manager is a singleton, just like all the other asset managers. It has a storage map that maps string keys to terrain objects, and it has its own folder with a default path. So it has get and load, which are get is going to be log n time, just because you're finding a key in the map. And then at the end, you delete everything, you clear out everything in the map, which is done in Gemini. Gemini unload content. I just unload everything, including the terrain objects now, using an attorney so that other people can't delete it. So that's the object manager. Oh, there is a default null terrain object right here. It does nothing at all, but this way things don't crash if you don't set a terrain. In the scene, I actually go ahead and set the null terrain in the initialize no matter what, so you don't run into that problem. For the terrain object itself, the main things that it has are a pointer to the model, pointer to the text, the graphics object, and wireframe, just in case you need it. And then the AABB array is the cell array. So AABs have a bit more information than you need, but I just went with that route. So the cells are just a ton of AABBs all in an array. And then I have a normals array of vex as well. So when you load a terrain, you create a new one and you'd specify all the information that you want. And you create the terrain model with this function, which does all the stuff that we covered in 370. Basically, you're initializing the normals array and you're creating the new model, but then you delete the verts and try list because you don't need that anymore. Then you create the graphics object based on that model, and then you call build AABB array. So that basically loops through your it loops through however big your array is and gets the cell corners and builds the AABB array, so you're initializing all the information in there. So yeah, now you have all the cells initialized. In terms of the functions that you use, that the user can use, there's quite a few, but the main ones are getting the terrain position underneath a certain position, getting the terrain height underneath a certain position. So this basically returns a float. This returns the whole vect of the whole terrain position, and then terrain normal underneath a certain position, so you can get the normal underneath wherever you are. Right, so that's terrain objects. On the scene level, give me 1 second to find scene. I don't have a terrain manager per se. All I have is each scene has a pointer to a terrain object, because you can just set one terrain at a time in the scene. So yeah, I just have a direct pointer to that terrain object. When you set the terrain, all you're doing is getting that terrain key that you request, and then setting up that pointer, and then drawing it, or submitting it for draw registration. Because terrain objects, I forgot to mention, are drawables. So that if they're added to the drawable manager, when they're drawn every frame, that graphics object associated with the terrain will be drawn. Right, so I'm going to go ahead and show this scene. It's just a scene with a frigate in it. And I am using some of the methods, so I'm getting the terrain position underneath the object, and I'm showing the marker there. I'm also drawing let me uncomment this really quick. So I'm getting the normal underneath the terrain and drawing it, and I'm also adjusting the spaceship to follow the curvature of the terrain. Okay. I'm showing this stuff there because I have the collision set up. But as you can see, there's a marker on each terrain cell, and the draw line for the normal is that green line. And even if I go to the edge of the terrain, give me a second, nothing will crash. The ship flips upside down because of how we're doing the orientation, but yeah, nothing breaks. And you can see all the information here in the screen log. So next is collision with terrain. While I'm right here, I'm actually going to comment out this normal stuff. So like that, and then comment out this. Okay, so for terrain collision, you set that up at the scene level. So in your scene, you say set collision terrain with whatever game object type that you want. This will create a new collision test command, the test terrain command, with a pointer to that collidable group. And then when this test command gets executed, first you have to calculate the rectangle area underneath the object. You're looping through all the objects in the collidable collection, and you need to create that square of cells underneath it. So basically I'm just using this constructor that takes the collidable, and it's this terrain rectangle area. So you compute a AABB based on the object's internal B-sphere, and then based on like the top left and bottom right of that AABB, you get the min and max I and j. Those are the indices of the corners of the list of terrain cell boxes, if that makes sense. Then back to the test command. You loop through all of the cells using the iterator. Every time you are testing the collision between the object's B-sphere and that cell AABB. If that goes through, then you test the actual AABB with the object's actual collision volume. Right, and then the iterator works like so. It basically, when you go to the next one, it calculates the next one and loops around based on the min and max ij that we calculated earlier of that rectangle area. So, right, you loop through all the cells. There's no copying of anything. You're just pointing directly to the cells and test the B-spheres and then the actual collision volume. So I'm going to run this again and actually collide with the terrain. So if I go to a wall, you can see right now it's turning yellow because I'm colliding with the B-sphere. And then if I go a bit farther, I collide with the actual collision volume and kick out. So, and you can see it's printing right here. There's also, oh well, first I'm going to go to the edge and just show that it doesn't crash. So even if I go off the edge, nothing bad happens, we're still fine. So all that's working fine. And then while I'm colliding, and I have this red box is showing, I'm also doing the collision callback on the frigate collision terrain right here. Because in the test command, when you actually collide with something, you call collision terrain on that collidable. So yes, that is everything to do with terrain.